Dang, my muscles are so weak.
I feel that. I haven't been able to touch my toes in years.
Oh, I wish my muscles were made out of carbon fibers and carbon nanotubes.
Carbon nanotubes? What are those?
Carbon nanotubes are well known for their outstanding tensile strength, but they have other properties that attract scientists and researchers to study extensively for the past 20 years. The mechanical properties of high flexibility for carbon nanotube makes them ideal for the use of structural polymer composite. Without the ductile and bendable properties, carbon nanotube would be very restricted in applications for flat panel displays and automotive area. Currently, the lowest carbon nanotubes density is around 1.3 to 1.4 grams per centimeter cubic. It is about a ninth of copper density and a third of aluminum density. And the latter one is famous for light metal materials in the field of aerospace, which means the use of carbon nanotube would be revolutionary in the automotive and aerospace components with lower mass yet robust strength. Another important property of carbon nanotube is their great electrical conductivity. Based on the average conductivity of carbon nanotubes, which is between 10 to the power of 6 to the 10 to the power of 7 Siemens per meter, they have compatible electron carrying ability with two of the best metal conductors, copper and silver. Carbon nanotubes even have the advantage of high aspect ratio, which means they can reach the desired electrical conductivity with smaller addition in polymaterials. In this case, they are very ideal for making conductive composite materials.
Wow, that's pretty cool that there's a material that can do all of that. I wonder what gives it their unique structure and properties.
Actually, carbon nanotubes have their unique properties because of their structure. And those properties can actually be modified by varying the structure. So that's why it's useful in so many different areas.
The structure of carbon nanotubes can be imagined as rolling a sheet of graphene into a tube. These can either be single-walled carbon nanotubes, which have walls as thin as a single atom, or they can be multi-walled carbon nanotubes, which have several carbon nanotubes stacked inside each other. Some key properties of carbon nanotubes are their great thermal conductivity, electrical conductivity, their high tensile strength, and their flexibility. These traits are what make them so useful in so many areas. Additionally, carbon nanotubes can have several different configurations, which depend on the angle of the structure. If you imagine a carbon nanotube as a rolled up piece of paper, this would be the difference of, say, rolling up the sheet from one of its sides or from the corner. The three configurations are the armchair configuration, where the rows of carbon hexagons make up the length of the tube, zigzag, where the rows go around the tube, and chiral, which is any other angle. The structures of these tubes are what determines their function, and when the structures are edited, the function is modified as well. The structure is what makes the carbon nanotube so strong and flexible. Carbon nanotubes have sp2 carbon bonds, which are great because they're hard to break and even stronger than diamond. This is because sp2 bonds have greater S character than the sp3 carbon bonds that we would see in a diamond. In addition, the rolled up structure makes it stronger than graphene, just like a rolled up piece of paper is stronger than a sheet. The length and diameter of a carbon nanotube also affect the thermal and electrical conductivity. To a certain point, increasing the length and diameter increases the conductivity because it allows for phonons of longer wavelengths to go through, because the structure is made more compact at greater diameters, and because electrons find an easier path through the structure. This has its limits, however, because when the tube is too long or too wide, it tends to get imperfections, which inhibit the conductivity. Lastly, the chirality has a great effect on the tube because it determines whether it's metallic or semiconductor. The armchair configuration is always metallic, while the other configurations can be either, depending on how the exact structure is made up. Because the structure is easily modified, the function becomes variable as well. This variability is one of the major reasons why carbon nanotubes are useful in so many areas, since they can be modified to fit the purpose.
Wow, I wonder how a material like that actually came about. Yeah, it's actually a really cool history.
The discovery of carbon nanotubes, another allotrope of carbon, is often accredited to Sumio Iijima of Japan, who published his findings in Nature in 1991. Iijima discovered carbon nanotubes while looking at the insoluble material of arc-burning graphite rods under an electron microscope, in which he saw tiny carbon tubes stacked within tubes. Iijima was inspired by the 1985 discovery of fullerenes, which used the same electron microscopy methods that Iijima helped create and later used to discover the carbon nanotubes. He named these substances carbon nanotubes due to their tubular structure of carbon atom sheets, and a thickness that is less than a few nanometers. Here he described multi-walled carbon nanotubes, but it wasn't until 1993 that he, along with Toshinari Kari and other scientists at IBM, discovered single-walled carbon nanotubes by using transition metal catalyzed arc discharge. Though Iijima put carbon nanotubes on the map, it's important to note that they were first described by two Soviet scientists in 1952 with the publication in the journal Physical Chemistry of Russia. Then, in 1979, Peter Wiles and John Abrahamson were investigating the carbon fibers produced when sparks were passed between two graphite electrodes. They found massive small fibers on one of these electrodes, presenting evidence of carbon nanotubes as carbon fibers produced on a carbon anode during an arc discharge.
Carbon nanotubes aren't even that interesting. I bet they're only used in specific cases.
That's not true. Carbon nanotubes have applications across multiple fields, such as superconductors, drug delivery, and even spacecraft.
Carbon nanotubes have many different applications due to their unique properties. Now, I'll be talking about some of the more significant applications as well as their implications for the future. The first main application is in biochemical sciences in the form of targeted drug delivery. Now, targeted drug delivery increases the concentration of a drug in a specific area of the body in order to improve the efficiency of treatment. Now, carbon nanotubes are able to improve the efficiency of this treatment significantly. However, any impurities will likely cause damage to the body, requiring carbon nanotubes to be extremely highly pure. By combining carbon nanotubes with hydrogels, as seen in this process below, these are images of hydrogels, the risk of toxicity of the carbon nanotubes due to the impurities are lowered, and the carbon nanotubes become more pure. Now, the reason that these carbon nanotubes are so helpful for targeted drug delivery is that their electrical conductivity stabilizes the drug molecules. This means that treatment lasts for longer and is more efficient to a specific area of the body. Now, this is so important because it will revolutionize developments in targeted drug delivery and make medicine more accessible for everyone nationally. Now, in terms of energy storage, carbon nanotubes are also extremely significant. Lithium-ion batteries and supercapacitors are the most widely used currently for energy storage, and carbon nanotubes can be interspersed in the cathode as shown here in order to improve the conductivity and efficiency of that cathode. Now, carbon nanotubes can also be synthesized as electrodes just on their own, as seen in this image below. Now, this makes the electrode extremely lightweight and flexible, as we know are characteristic of carbon nanotubes. The reason that this is so important is because improving storage efficiency in lithium-ion batteries and supercapacitors means that less power is wasted and can lead to new developments in the fields of energy conservation. Carbon nanotubes as electrodes themselves make them, again, flexible and lightweight without losing any conductivity, and this makes them more applicable across a broad number of fields.
Wow, I'm so glad we learned about carbon nanotubes, but my muscles are still really weak.
I know, I still can't stretch either.